Hello guys, it's me again. Welcome back to another episode of Talks Writers. In this video we want to talk about how to create automation inside ParaView, how we can make things go automatically in this sort of stuff. So, automation on ParaView. The use case I want to show you is again related to the cell viability project, which was the first project with which we started to demonstrate post-processing capabilities inside ParaView. But in this video, I want to show you how you can create some sort of scripts, Python scripts, and also some macros to facilitate, daily tasks, or also they can make life much easier for us in lots of cases. For example, in this case, in very similar to the previous cell viability simulation that I showed you. We have oxygen consumption inside wells, but in this time we have two wells indeed. And we have already created a simulation workflow that automatically generates domains with two islets, but the workflow automatically indeed increases the distance of these two islets and conduct a new simulations, performs a new simulations, and then writes this output to specific folders. In this case, we want to have again similar to the previous post-processing of cell viability things. We want to have the change of oxygens over a horizontal line, but we want to do that in an automatic way such that we can have a plot like this. So what we can do in traditional way, we can open just, for example, the files output for one of the workflows. We can open each file separately and then do the things that you saw in the previous videos, plotting the lines, saving the output, and then putting them all together. But just imagine that when you want to do that for more than 100 cases, then it becomes a very boring and time-consuming process. So we can ask ParaView to do that for us. But the thing is, it requires also a bit of some knowledge of Python programming, because Python is the language for this kind of automation in ParaView. But I will show you how to do that. You don't need to write everything from scratch. ParaView does, a big portion of that for you, but you should know how to utilize that. Before going to ParaView, let me quickly talk about some of the naming convention that you will see here. The thing is, these numbers are indeed, for example, in this case, the first number is for the diameter of the eyelet, or two eyelets, and the second number is indeed the distance between the eyelets. So that was the design of the simulation workflow. So it was like, in this case, the distance is 150 micrometer, and then then we will increase the distances by 100 micrometer, and then we have all the results together. So this is indeed the results. For that, I will start first ParaView, but I have also the code, the final code that we want to develop here, but you can download from the link in the description. But the thing is, I want to show you how I have created this code, and this code will not necessarily work with this specific version of ParaView, so we will start to write it ourselves. But the thing is, very similar to previous workflows. Just imagine that I want to open this. So this is indeed the workflow that I should take in order to go on with the quantitative output I want, with generating the quantitative output. So the thing is, this is the consumption of oxygen, you know, this is the last step, so I don't have any animation. The files, the VTK files, are indeed the last step of the animations. And then I want to have a plot over line, which is indeed this one, of this file. So something like this, because then they will go far from each other. So I want the line to be big enough to be inclusive. So something like this, you know, this is just very rough and estimation of things, so I don't want to adjust the points accurately. I click apply and then displays me something like this, but this is not what I want, so I close this, I open a new spreadsheet view, and then with this plot over line I export the data and save it somewhere. And you know that, for example, on this data for the scalar one, I have the value for the change over this, for the change of oxygen concentration over this horizontal line. This is the manual work, but how we can automate it? The thing is, there is a very nice feature in ParaView that indeed is intended to create macros out of it. You can create macros that they just do things automatic for you. And there is a tracing feature in ParaView that creates those macros. But the thing is, in the end of this process of tracing, it shows you the Python code that indeed builds that specific macro. So we can take advantage of this feature to get those automation workflow and processes out of ParaView tasks. So you don't need to write things from scratch. ParaView can do that for you. Let's see how it works. So I reset the session and I do all these things, but before that I start tracing. So I start tracing. It says that what you want to save. I say any modified property or all properties, so just the modified properties. So the defaults, like the defaults of the classes of Python classes will be already out there. So I'm in the tracing mode. So I open the file that I want to open. So it was in the cell viability automation files. I open one of the files, for example this one. It doesn't matter at this point. I click apply. Then I switch to this representation. It's not important for us because in the code, in the automated code, we don't want to have this sort of animation, sorry, graphical representation, but I just want to see it at this moment. So I click apply. It opens something like this for me. Then I close this and then I open a new spreadsheet view, and I have the value for scalar 1 there, not a number. Why? Maybe because the z is not 0. Yeah, that's the reason. Click apply. Yeah, sometimes it happens because of the, maybe, I don't know, some bugs in the camera orientation. Apparently I'm in a 2D surface, but sometimes, yeah, the z value you saw, that was a very small number. So now I have everything here, and then I click export and I save it somewhere, like in a desktop. I will say that test.csv and click OK, and that's all the process that I want to automate. So I click stop tracing. So this is indeed the Python file that ParaView has generated for me. I can take advantage of this to make it automatic. So the building block is already created for you here. So I have a Python code here. Let me open it with another editor like a Tom. Yeah, I think the font size is big enough for you to see. So yeah. First of all, I have here, you know, I don't want to talk about Python at this stage, but the thing is, we just check if it is the main file that is being run by the Python interpreter, then do this. And then we have also a function that I have called it save CSV, that asks accepts a file name as a string and then tries to write the CSV file to the disk. But the thing is, this automation code indeed works like it lists all the files in a specific directory. In this case it is output, but I need to change it to files, so I have to change it to files. And then it says if file starts with oxy. Let's double check that it works. Yeah, it says that the oxy is there, and then with some regular expressions it gets the number for this current run, and it is split it, so the size and the distance can be obtained from this. So for example 150 and 100 will be put in these variables, and then it prints it on the screen and then calls the save CSV file with the file with this string as the input. So it comes here, and this is indeed the rest of the process inside ParaView. So what I need from this is indeed let me remove this one. I don't want this one. Maybe the file is important. Why I do not run this? Because this is as I told you, this is generated in another version of ParaView. I'm not sure what happens if I run it at this moment. I want to just keep a couple of lines here. These are indeed the two lines that I need. I will put it here. That is reading the file name, which is inside files, and writing the output to the folder CSV. So I should remember that I need a CSV folder here as well. So let's bring this code here. These are the lines. This is indeed loading the ParaView module inside Python. And then for the rest, I need them indeed. So from here to the place that it saves, it exports the CSV file. So I need it here. I can copy the whole things here. So this is the code, but I have to follow the indentation requirements of Python. So, and also here it says that open this file name, but instead of this is indeed a line that I kept here for this moment indeed. So instead of this one, I want that one, but the name should be the same. This is indeed, and the file name would come from the file name, and then in the end there is nothing. So yeah, everything exactly the same. So the rest I keep them because these are things generated by ParaView. And also for the export view, I want to show you the CSV file that is created. So this is indeed the CSV file for the that is generated by ParaView, and this is indeed a scalar that I can plot. But yeah, this is for the previous one. Yeah. But anyway, here, and instead of that, I want to save it with this syntax. So yeah, cool. And then everything else is ready. I should run this script in the Python, but there was some consideration for that. It just does all the rest, and then it saves it into the desired file that I want. And this syntax, because the file name comes with the VTU or VTK extension, I have to trim those parts and then add the CSV extension. So it saves separate CSV files for each of the VTK files. But then how to run this? The thing is, let me open a new terminal window here. for the code that I have. So a new terminal window, I think the font size is big enough. So the thing is, the Python, this ParaView package. Let's see what happens if I want to call this, if I want to run this statement here in a normal Python. In a normal Python, when I run that statement, this statement indeed, it says that no module name ParaView. The reason for that is this is indeed comes with ParaView. There are some steps that you should take and add some Python passes so the Python interpreter can find the module, or there is another solution provided by ParaView developers, is a specific version of Python that is released that comes with ParaView called PvPython, and PvPython is indeed a recent version of Python, but preloaded with all the modules that you need to work with ParaView. So if I paste it here, you see that it indeed initiate a version, you know, a ParaView server that is waiting for me to give some commands to that. But then it didn't complain about that lack of ParaView module. So this is indeed the command that I need to run my script with. So I should say PvPython and then a code. I don't expect it to run, but let's see what happens. So it says that a non-type object has no attribute collapse, and the reason for that is, at some cases, I don't know when and why, this object, let me show you what is that. I think it is collapse. This layout object inside ParaView becomes null, or in Python it's non-type, it says. So it doesn't work in this way, but the automation script is still there, and we can ask ParaView to run that for us. But how to do that? Let me reset the session. So in this way, I will ask ParaView, already initiated instance of ParaView, to run this script, and in this way we just become sure that there is no null or non-type errors. So this is indeed a way that you, most of the times, you can easily run it. But I'm not sure what's the issue in this case. That maybe this is because I have a customized ParaView, but apparently I cannot run it from command line. But this is indeed the way that you may be able to. So I run it from here, but how to do that? In order to do that, I should use this Python shell. So Python shell is something, as you can see, this is again, it says that yeah, this package is available. So this is indeed PvPython, and it has a run script button here. So I can say that please run this code file for me. I don't expect it to work, but I will tell you why. But let's see what happens. So it ran without any error, but the thing is, the problem is in this line. This line, it says that if name is main, it means that if I have run it with this kind of syntax PvPython code, but at this case I don't have it run using this technique. So I should remove this line. I can comment it, and then for the indentation, in order to avoid them be part of the save CSV function, I should bring them back, and then I think ParaView should be able to run it. Let's try it this time, see what happens. It says no such file or directory files. Oh, because I didn't run at this moment ParaView. The current folder of ParaView is somewhere else. It's called current working directory usually. So I have to run ParaView from here to be sure that ParaView knows where the files folder is. So I run this one, and then you see that it starts to but yeah, it starts to generate the files, generates the automation workflow for me. I made a mistake here. I think maybe ParaView didn't capture that automatically for me, but apparently I should have paid attention to this. Yeah, I think these are wrong apparently, because at least, for example, the X coordinates should be the same. So this is indeed wrong, as you can see. Point source is inserted here wrong, but I didn't have any clue of that. So you should run it and then see that, okay, something is wrong, for example, in ParaView script, and then you should correct the errors. So in this way, let's have a look at the CSV outputs. Oh, everything is created here. For me, all the CSV files are saved, and you can see this is my print statements in the code. I mean, here, all these print statements that are telling me at which file at this point this script is working on. Yeah, let me also fix the line issue here. So for the lines, it should be somewhere between here and here. So the x value should be this, and for the y, oh sorry, it should be, there is a different, it should be the same value for y, not x. I'm so sorry, it should be there because there is, this is a horizontal line, and for the y, from this, for the x, sorry, for the x, this value from this one to this one, and then it should be okay. And the z is 0. Oh, I'm changing the camera. Again, I made a mistake, and so this is indeed the case. This is indeed the case, and the problem, oh, I'm so sorry. So I have to change the y-axis. Sorry for making a mistake. The y should be the same, and the x1 for point 1 is indeed this one, not 0, of course, and for x2 it is this one. Always changing just the camera position. These are the lines that I don't need at all. I can, you know, make them all commented. So now let's run it again to see what happens. I reset a session, and for this one I run the script. Now this time invalid token. The reason is I had forgotten to put the, it's here, the second camera. Why am I mixing camera with this? So this is indeed how it should be. It should be something like this. Hopefully it works. It works now in the code, and then it starts to generate the plots for us. So, you know, I didn't stop the video at the time that the mistake happened, just to show you that never afraid of fixing the bugs. So go to the code, even if it is something like this that you find it complex. I made a mistake in the beginning that I was just positioning the camera location, but indeed this is indeed this is where I should have put those values, and then you can see that now everything is correct, and indeed the automation works pretty well, and it has produced these files for me, and they all contain those graphs. So after this you can make even some automation on this script to automatically load those CSV files and extract only that specific column for the scalar, and then put them all together and yeah, that will complete this automation, but then it will become more something like a Python stuff and not ParaView, so I've just ignored that part. But indeed, in the main workflow, I had that code as well to generate something like this. And that was it. And this is indeed how the automation can work in ParaView. You can have this tracing stuff, and at the time that you have this tracing, let me show you. For example, just imagine that I change this and I click apply and then I stop tracing. You can save this Python file as macro, and then that macro would be available here. For example, for previous videos, for the construction of the vector field, you can have some macros that generates the field automatically for you, and this is the way that you can create them using save as macro option in the trace window. So I hope you enjoy it, and just try to work with this code yourself and have some automation out of this data set that I have provided for you, but also for your own files. So this is indeed was the last video I intended to record for post-processing, which also became a long video, but yeah, I think it is worth because yeah, I show you how to debug some problems that may occur because of this the behavior, some weird behavior of ParaView that happened. So yeah, have fun and see you in next series of Tax Riders. Bye.